Okay, let's look at this question from DocSci Ex. It's question 7 from exercise 15 in the electrostatics chapter. It says to you, the electrostatic force between two identical point charges is 6,44 times 10 to the negative 3 newtons. The distance between the charges is 2 centimeters. Calculate the magnitude of the point charges. So the first thing we know is we're going to use this formula. The force is equal to K Q1 Q2 over R squared. So here's the value of K from your data sheet. Now remember, now I can't type fractions in here easily. So let's have a look what we're going to do in this calculation. The first thing is, it says the point charges are identical. So Q1 is equal to Q2. Okay, so what we're going to do in the formula here is we're going to call this Q squared. Okay, and then what is the other thing that they've told us? R equals 2 centimeters. Can I put 2 centimeters into the formula? No, I may not. It is not an SI unit, so I have to turn that 2 centimeters into meters. So it is 0,02 meters. So now I'm going to write my formula out, and remember I'm going to use divide for the fraction. So F equals K, and now it's going to be Q squared, yes, times, okay, it's not times, it's divided by, because it's Q1, Q2 now becomes Q squared over, yes, divided by R squared, 0,02 to the power 2. Okay, so what will my force be? You need to put this into your calculator. Okay, we had the force here, yes, they told us the force, so I should have inserted this force already. So 6 comma whatever equals, okay, equals this value, 9 times 10 to the 9. Okay, so that is K times Q squared. This typing thing in this thing is a pain in the butt. Okay, divided by 0,02 squared. Okay, so now by the power invested in you by algebra, okay, you should be able to work this out. So pray for your teacher and her calculator and her algebra. I end up with something like 2,86 times 10 to the power of negative 16 equals Q squared. Okay, so then all you have to do now is root this, okay, because the charges are identical. So you just find the root of your answer, and then I get 1,69 times 10 to the negative 8, and it's a charge, so it's in coulombs, so that is what is equal to Q, and that looks like about the right size charge. So that would be your final answer. So you just insert everything into the formula and look for the unknown, remembering that if the forces are identical, Q1, Q2 becomes Q squared, and then you just root your answer. Quite easily done.